Again, remembering from the lecture today, earlier, that PWM is about adjusting the duty cycle of the duration of a pulse on the digital pin. How fast that pulse happens is depending on which prescaler and which timer are used, which you'll never really have to worry about unless you're getting into some pretty ornate project. Normally you'll just use what comes out of the box. So that's many, many thousands of times per second, many, many thousands of cycles per second. And we select the length of the duty cycle, so how long, so you've got this regular cycle that's happening, okay? The duration of that cycle that you stay on is the duty cycle. How long it's on. 50%, 100%, 25%, 100%. If it's 100%, then there's always a pulse digital high on that duty cycle. There's always a digital high pulse. That means that you've got 5 volts on that pin all the time. Okay? But you can write the duty cycle to be lower. So 255 is always on. And the amount of value you write is a byte, so you can go from 0 to 255. So a half of a duty cycle is half of 255, which is 127. 0 duty cycle is 0. 25% duty cycle is somewhere halfway between 0 and 127, right? What is that? Can't recall. So what we're doing then is we're using the analog write function to set the duty cycle. So here we've got LED pin 9. You've seen that before. Okay, nothing in setup. Although, technically speaking, this should say, what should it say? Yeah. And now what? Correct. Great. So that's better. It's not the end of the world, but more reliable that way. So let's take a look at the loop here. So the key function is analog write here. Why is it analog write when clearly it's connected to a digital pin? Right? This is a digital pin. Any thoughts?
It's emulating it.
Correct. Yes, it's emulating an analog signal. It's not really an analog signal. We're still only switching this pin on and off. But it looks analog. It looks and feels analog. I mean, it will still have, if you looked at it with an oscilloscope, you would still see essentially staircase effect, the way you would see with any kind of pixelation, okay? Because it's really only turning it on and off. But it's happening so fast that it has this effect of being a general sweeping wave. So the duty cycle is gradually increasing, and it looks more and more like a smooth curve, even though it's still only happening it's only +5 or 0. So what we're doing here then is we're analog writing to a digital pin 9, and this fade value is drawn from this simple loop here, where we're fading from 0. As long as it's less than 255, then we're keeping on incrementing upwards by 5, right? And then there's a delay. Any ideas why that delay is there? No? Okay. Let's see what happens if there's no delay. Okay. Or I could also just comment it out. Take a look. So let's upload that to the board. Plug myself back in. I'm going to take the probe off. Okay. Well, it's hard to see, but what's going on is that you're only getting the last half, that second half of this loop here. Let's take the delay out of here too. Go back, upload that to the board. You kind of see it, it's flickering a little bit. But it's going so fast now that you can't, it is actually going from 0 to 255 still, okay? But it's going so fast that it's almost imperceptible, right? So the delay is in there so that we can have at least some amount of delay that we're now into the range of human vision, because we can only process things so quickly with our visual capabilities, which is why motion pictures work. So so that's what that delay is doing in there. If I take that, put that back in, I've also got this over here, this fade value. What is this doing? This is just incrementing the steps. So if I change this and make it lower, what's going to happen? Any guesses before it gets there? Yeah, it's going to go a lot slower. Well, somewhat slower. All right, it gets bright and then it fades gradually away. Right. You will notice that, wow, it's a lot slower than I expected. You will notice that it doesn't, at the very end, let's put this back to like 5. At the very end of the fade, you will see that it does not appear to go in a linear manner. It goes, if we were to graph this, it kind of gradually sweeps and then gets dark and then it blinks back on. It doesn't seem to go, 0, 255, the light is fully on, back to 0, back to 2. It doesn't look like this. It kind of almost winks right here at the bottom. Do you agree, or am I wrong? I think it kind of winks a little bit. It's not linear, and that's not to do with what's going on here. That's to do with how we see, because of the way we process light perception is nonlinear. Like hearing, like with audio, you have this sort of logarithmic effect. Same thing for light perception. You don't see it in a linear way. So since we're incrementing this up and down in a linear manner, it has this effect of looking like it's kind of winking out. So the smoothing, the fading doesn't look quite as smooth as you might expect it to look. Okay. So, but let's just demonstrate for a fact that that it is moving in a linear manner, right? It's literally counting properly. So I don't think I discussed this with you last week. Some of you might be aware of this, some of you might not. On the Arduino, there is a channel of communication with the laptop, which is the serial port, okay? So we can use the serial port for some very convenient things. Mainly, it's very helpful for diagnostic, but it can also be used to send data to other programs like processing or pure data or, or the internet, right? If you wanted to send a tweet, you could send some data over the serial connection from the Arduino to maybe Python or a script or something, some program that's listening for it, and then pass that onto the internet. Or if you want, you could put the connection to the internet directly onto the Arduino itself. All right, you get a way of accessing this serial port. So we can do that in a sketch by instantiating a serial port. And it's also important to note that the serial port, although it's happening over USB, it's also happening over the 0 and 1 digital pins of the Arduino. So this is a Mega, but it goes the same for the other series of Arduinos. That pin 0 and 1 are how is the serial channel created in the sketch. We first instantiate the channel, and we set a speed, which is by convention 9600 BPS. You can set it to, I think, 115,200. You can certainly set it to 57.6. 9600 is fast enough for many purposes. So now I've created the serial channel, and these values are. So I'm going to report here, capital S. Don't make the mistake of not using capital S. Print line. You can do serial print, but then you'll just get them in a sequence. There will be no carriage return, so usually print line is better. And what are we going to print here? I think we'll probably print fade value to see what that fade is. I'm going to copy this text to the second section of the code, and we will hopefully see the results. Okay. Now, we need some way, we're uploading it hopefully, we need some way of monitoring that serial communication channel And that's what this here is for. This icon is the serial monitor. If you instantiate that, or if you click it rather, you will get a serial connection, and we can now see that the numbers are indeed going up and down. All right. Create a serial monitor window. It resets the board. It restarts the sketch. Okay, so if I close that window and start it over again, it's like pressing the reset button. Okay. I can also change the apparent. I can make this communication 57600 faster. So if you've got a situation where you want a faster report of the output, you can do that. I'll send that up to the board, make sure it's gone. You notice I didn't bother compiling it. Okay, so now there's no obvious difference on the board. It's still doing what it was doing before, but now in the serial monitor, if I start it up, I get all this gibberish. The reason I'm getting all this gibberish and garbage is because the baud rate is not matching what I set in the sketch. Okay, so if I set that to be 57.6, also you start to overload. You can start to overload the buffer here if you leave the baud rates not matched for long enough. Your computer will slow down because it can't cope with this little problem. So I'll get the pinwheel, and hopefully it will. I can set this to be the proper baud rate. You want to kind of set this quite quickly. Come on, you. Well, in any case, what you'll notice is when I've set the baud rate to be higher, I get a faster report of the output. Okay, so those numbers will update more promptly. But that doesn't mean they're changing any faster. It's just that the reported updated values on the serial monitor are being reported faster. Okay, so are there any questions about how that's working?